Hello guys, welcome to this tutorial video. In this video we're going to treat how to do the power rule of differentiation, and we are also going to talk about the polynomial rule, which is basically a combination of the power rule for various terms. This is actually the introduction to calculus. It's the first video I'll be uploading concerning calculus. There are more videos and more things to do in calculus, so I'm going to be uploading more videos in that. I encourage you to subscribe to this channel and also to click the notification button, plus make sure to always drop comments in the section below so that I could get your input and your questions and any contribution or corrections you would think may be needed to be made. But in this video we're just going to treat the introductory part of calculus, which is the power rule of differentiation, the basic rule of differentiation, and then we'll also look at what power rule means. So as you can see here, we have a statement of the power rule. I'm going to call this the power rule. So we have the power rule. So if f of x equal to y is equal to x raised to the power of n, then f prime of x, which is the same thing as dy dx, is equal to n multiplied by x raised to the power of n minus 1. So what that means is, if you have a function like this function is actually called the power function. If you call that power function y, that is, you give it the subject y, or you decide to just call it by the normal name f of x, that is f a function in terms of x, and you want to find the derivative of such a function, if you use this, then you're supposed to represent it as f prime of x, but if you use y, then you're supposed to represent it as dy dx. So now let's take some examples so that you see just what I'm trying to talk about here. So in the first case, let's see, if you have y is equal to x raised to the power of 3, what will be the answer if you were to find dy dx? So if I were to find dy dx in this case, I'm going to do what happens here to bring the power down, like you can see here. So I'd bring the 3 down, and then I'd subtract 1 from that 3, as you can see here. So we have 3 minus 1. So the answer would be equal to 3x squared. So this is the final answer for the derivative of this function. Differentiation of a function is also called the derivative of a function. And you may be asked in a question where they are even demanding for you to tell the gradient of a function or the equation of a line. It's also still talking about the derivative of such a function. Now, what if we were given another function like this? We have x raised to the power of minus 7. Feel free to pause the video and try this part yourself, and then you come back to check. So if you were to find the derivative of this, that is dy dx, you bring the minus 7 to the front. So we have minus 7x minus 7 minus 1. So I just subtracted 1 from that power, like it's normal for me to do using the power rule. So we have minus 7x raised to the power of minus 8. So this becomes the answer for this question here. Now, before we go on, I want you to realize that actually the derivative of a constant is 0. So if I had y is equal to 3 and I was to find dy dx, dy dx is actually 0. Constants, every constant is equal to 0. 0 is also a constant, so if you were to differentiate 0, the answer is still 0. So any number you were to differentiate, if that number is on its own, that is, it's not attached to any variable, then the derivative of that constant is 0. So know that the derivative of a constant is equal to 0. So if you were differentiating any constant, make sure to remember that the derivative of that constant is going to be equal to 0. Now try this on your own. If you have y is equal to minus 3x raised to the power of minus 10, how would you solve that? So this is actually a coefficient, though it may be called, you may think of it as a constant, but actually it's not a constant in this case. Actually, we're calling it the coefficient in this case. So our dy dx in this case, you just make the minus 3 to be outside the bracket in which you perform your differentiation. So actually the coefficients of terms in a function don't actually participate in the differentiation, you always keep it outside. So is the minus term I'm to bring down, then subtract 1 from the minus 10. So the answer here is supposed to be minus 3 multiplied by minus 10, which is positive 30, x raised to the power of minus 11. So this will be the answer for this third case here. And if you had something like this, something like y is equal to 2 over x raised to the power of 3. So here you have something like 2 over x raised to the power of 3. How would you solve that? The first thing you need to do here is the knowledge of your indices. If you know the laws of indices, there is a video that I'm going to upload soon on how to get the laws of indices and how to calculate indicial equations. Make sure to subscribe to this channel so that you see that, and if you click the notification button, you'd always see that when I upload those videos there. So you need to make this to become a common term so that this x is raised to the power of minus 3. So it's the law of indices that say if I want to bring this x to this place up to make it be in the same plane or in the same line with 2, then that means I need to introduce a negative in front of that power. It's according to a law of indices. So this is actually the term that we are going to differentiate. So if we are to differentiate that, dy dx going to be equal to, since this is multiplied by the variable here, this is not a constant but will be called a coefficient here. So we put the coefficient outside and then bring our negative 3 to the front, then subtract 1 from the negative 3. So we have minus 6 x raised to the power of minus 4. So that is the answer here. Now try this last question. If you have y is equal to 7 over 8 x raised to the power of minus 10, how would you solve such an expression as this? It's quite simple, very simple. The thing you need to know is that 7 over 8 is also a coefficient, though it's a fraction here, but it's still a coefficient of that expression. So it's what you're going to put outside. So this is 7 over 8, and then you open your brackets and perform your differentiation on this or in this term. So that's minus 10 x raised to the power of minus 10 minus 1. So this is equal to 7 over 8 multiplied by minus 10 x raised to the power of minus 11. So if you were to multiply 7 over 8 by this minus 10, 7 times minus 10 is minus 70 over 8, then we have x raised to the power of minus 11. So if you were to separate or to reduce this fraction to its lowest term, we know 2 can go into this, so we'd have cancel out. We have 4 here, and if we cancel these out, we'd have 35 there. So we have minus 35 over 4 x raised to the power of minus 11. So this will be the final answer there. Now, if you were given some expressions and you were asked to find the derivative of that expression at x equal to some value, then that is the process of substitution. So if I said for this question, if y is equal to 2x raised to the power of minus 2 over 3, then find dy dx at x equal to minus 1, could be given such a question as this. If you were given such a question like this, how would you solve that? It's quite simple. The only thing you need to do is immediately after you get the derivative of that constant, replace wherever you see your x by minus 1, and then you get the substitution of that. So if y is equal to 2x raised to the power of minus 2 over 3, remember this is a coefficient, so it's outside. So we have minus 2 over 3 coming to the front, and then we have x raised to the power of minus 2 over 3 minus 1. So this is 2 multiplied by minus 2, which is minus 4 over 3. And then we have x raised to the power of minus 2 over 3 minus, I'd make this one to become a fraction in term of a way that the denominator of that fraction should be 3. So that obviously should be 3 over 3. I'm doing this because if I have two fractions that are having a mathematical operation with themselves, where the denominators are equal, then that means I can just perform the calculation on top, just the numerators on top. So that means I can just say minus 2 minus 3 if I have 3 over 3, because these are the same denominators. So we have minus 4 over 3 x raised to the power of minus 5 over 3. So this now becomes the final answer. But this won't be the final answer because we were asked to differentiate this at x raised to the power of minus 1. So this is where you introduce your calculators. If you have minus 4 over 3, have minus 1 raised to the power of minus 5 over 3. Now, if you had this, you use your calculator and you get the answer there. So if you were to use your calculator, what would be the answer you'd find? So let's try that here. If we have minus 4 over 3 multiplied by minus 1, close bracket, and then raise it to the power of minus 5 over 3. That will be equal to 4 over 3. So this is equal to 4 over 3 as a final answer. So that's just how to do a differentiation where you're asked to substitute the value of x at any term. So that's how to do the power rule of differentiation. So what is it all about? Polynomial rule. The polynomial rule is just a kind of combination of the power rule where you have binomial expressions, or you have linear equations, or quadratic equations, or polynomial equations. The only thing you need to do is to differentiate all those. So the polynomial rule says if you have y is equal to u plus or minus v, u is a different function from v. So if you had these two different functions, then dy dx is du plus or minus dv. That means you should just differentiate all the functions separately as you go on. So here we are with this question here. We have if y is equal to 140, x squared is equal to x raised to the power of minus 3 plus 14x raised to the power of minus 10, find dy dx. What is dy dx there? So you should feel free to pause this video and try this by yourself. So if you were to differentiate this, if you were to find dy dx, for this case, remember these numbers that are in front of these variables are all coefficients. So we have 140. So we bring our 2 to the front and then subtract 1 from the 2. So you can see that the differentiation actually takes place with only the variable. The coefficient of that variable always stays outside. But if we only had 140 here, then that means the derivative of 140 should have been 0. Because this is attached to this by multiplication, and that means you put this outside and do the differentiation there, and then you multiply it later on. So we have minus 3x raised to the power of minus 3 minus 1 plus 14 into, okay, I'd bring minus 10 to the front. So we have minus 10 x raised to the power of minus 10 minus 1. So this would be now equal to 140 multiplied by 2 is 280, x raised to the power of 1. Then we have negative multiplied by negative is positive, 3x raised to the power of minus 4. Then we have plus 14 multiplied by minus 10 is minus 140. Have x raised to the power of minus 11. So this would be the final answer for that case you are asked there. So there is another question that they may give you in such a case that you have an expression such as this and you are asked to differentiate or find the derivative of that function at x equal to some value. So let's try that case and see how you would solve it if you were given something like that. So let's say you had y is equal to minus 7 over 8 x raised to the power of 4 plus 3 x raised to the power of minus 3 minus 9 over x raised to the power of minus 2. So if we had something like this, how would you solve it? So let's say you're asked that find dy dx at x equal to 2. So if you were to substitute 2 into this, this is after differentiating this expression before you substitute that x as 2 when you've differentiated it. So we have dy dx there. And this minus 7 over 8 is the coefficient. Do that minus 7 over 8 is a fraction in that term there, but is a coefficient. You keep it outside the bracket. So we have minus 7 over 8. Then go into the bracket and bring 4 down and subtract 1 from 4. Plus 3. Bring minus 3 down and subtract 1 from minus 3. Then in this case we have minus 9 multiplied by 1 over x raised to the power of minus 2. Now this case is so serious, you may want to ask, how did this come about? The thing is, if you want to differentiate this, the best way for you to do it is to bring this x raised to the power of minus 2 to the same line as 9 there. So let's go there. If you multiply this by 4, you'd have minus 28 over 8. So we have x raised to the power of 3. Then positive 3 multiplied by negative 3 should be negative 9. X raised to the power of minus 4. And then you have minus 9 times x raised to the power of minus 2. Remember, I told you that if you want to make the division sign or the fractional sign to disappear and you want to bring that thing down to come up, then you introduce a sign in front of it. So whichever power that thing carries, it must now be introduced with a negative. So that's the reason why we're introducing this negative. Actually, this negative came with the x here, but now we're introducing this negative. So this is equal to minus 28 over 8 x raised to the power of 3 minus 9x raised to the power of minus 4 minus 9x raised to the power of 2. So remember, we hadn't differentiated this term. Hope you can see that. We hadn't differentiated this term. So we need to differentiate it. We have minus 28 over 8 x raised to the power of 3 minus 9x raised to the power of minus 4, and this minus 9 2x raised to the power of 2 minus 1. So this will be equal to minus 28 over 8 x third minus 9x raised to the power of minus 4, and then you have minus 18x. So this would be the derivative of that function that you were given there, but then we need to differentiate this at x equal to 2. Remember, there was a question we were asked here that we should differentiate it with respect to x at x is equal to 2. So if we were to differentiate that at x is equal to 2, it's just to add 2 wherever we see our x. So this should be so. If you were to do this, you'd have minus 28 over 8 into 2 raised to the power of 3 minus 9 into 2 raised to the power of minus 4. Then you have minus 18 into 2. So what will be the answer we find here? We have minus 1033 over 16. So dy dx would be this at x equal to 2. So that is the final answer. So here again is the A1 Science Tutor. Make sure to subscribe to this video so that you can get more uploads of videos on calculus. And if you have any question for any of these parts of the video, make sure to drop those in the comment section below. Don't forget to share this video with your friends, and don't forget to subscribe to this channel for more that is on the way. Thank you.